Insertion in an AVL tree. To insert an element in the AVL tree, follow the following step. Insert the element in the AVL tree in the same way as the insertion is performed in the binary search tree. After insertion, check the balancing factor of each node. Case 1. After the insertion, the balancing factor of each node is either 0 or 1 or -1. In this case, the tree is considered to be balanced. Conclude the operation. Insert the next element if any. Next, the case 2. After the insertion, the balancing factor of at least one node is not 0 or 1 or -1. In this case, the tree is considered to be imbalanced. Perform the suitable rotation to balance the tree. After the tree is balanced, insert the next element if any. Consider an example. Consider AVL tree for the following sequence numbers that are 50, 20, 60, 10, 8, 15, 32, 46, 11, and 48. In this, the first element is 50. We need to insert 50 as a first node. The tree is balanced because 50's balancing factor is 0. So we need to insert 50 as a root node. The next element to be inserted is 20. 20 is less than 50. So we need to insert 20 in the 50's left subtree. We inserted 20 as a 50's left subtree. The tree is balanced with a balancing factor 0 and 1. Next element to be inserted is 60. 60 is greater than 50. So we need to insert 60 as a 50's right subtree. It is balanced because the balancing factors are 0, 0 and 0. The next element to be inserted is 10. 10 is less than 50 and less than 20. So 10 is inserted as a left subtree of 20. The tree is balanced with the balancing factors 0. Next element to be inserted is 8. 8 is less than 20, less than 10 and less than 50. So we need to insert 8 as a left subtree of 10. In this, the tree is not balanced because 20's balancing factor is -2. So to balance these, we need to consider a imbalanced node. The imbalanced node is 20. So we need to go for a rotation. Here the rotation is RR rotation. After this, 10 becomes a parent of 8 and 20. Next element to be inserted is 15. 15 is less than 50. So insert this as a 50's left subtree. And 15 is less than 20. So it is inserted as a 20's left node. It is imbalanced. To get an balanced tree, we need to go for a rotation. Here, the rotation followed is left-right rotation. After this rotation, 20 becomes a parent of 10 and 50. The next element to be inserted is 32. 32 is greater than 20. So we need to insert as a 20's right tree. And 32 is less than 50. So we need to insert this as a 50's left subtree. The tree is balanced. The next element to be inserted is 46. 46 is greater than 20. So we need to insert 46 as a 20 subtree. 46 is greater than 32. So we need to insert 46 as a 32's right subtree. We inserted. The tree is balanced. The next element is 11. 11 is less than 20. So we need to insert this as a left subtree of 20. 11 is less than 15. So 11 is a left subtree of 15. The tree is balanced. The next element to be inserted is 48. 48 is greater than 20. So we need to insert this 48 as a right subtree of 20. 48 is greater than 46. So it is a right subtree of 46. It is imbalanced. To balance this, we need to go for a rotation. In this, we follow the rotation is left rotation because the newly inserted is right subtree of 32. By following this LL rotation, 46 becomes a parent of 32 and 48. We go for left rotation. Then we can get a balanced tree with a balancing factors 0, -1 and 0. The balancing tree is here. This is a balanced tree.